Hi there, we're going to do some more examples with the substitution method. And you have the 4 steps written in your notes. Okay, refer back to those as needed. Okay, your notes here. I'm going to use the page that says solving systems of equations by substitution. We're going to use a few of these examples. I'm actually going to do these odd numbered questions. We're going to start with 3. We're going to do 3, 5, and 7. Today. Okay, so number 3, we have a system of equations. You'll notice that the first equation already has y isolated. Remember, step 1 in our 4-step process says to isolate one of the variables in one of the 2 equations. Solve for either x or for y. So if this is already done for you, you don't have to do anything for step 1. Okay, so step 1 has already been done for us. Y is isolated. So we go on to step 2. Step 2 says to take the expression from step 1 and substitute it into the other equation, okay? And sometimes we forget, where do I put it? Do I put it in place of x or do I put it in place of y? Well, in this case, we have solved for y in step 1. So y is isolated. That means y is equal to this expression. So this expression has to take the place of y in the other equation, okay, because it's equal to y. So you're going to substitute that expression right in there, all right? That's going to give you this, 5x minus 4 times the quantity, negative 3x plus 5, just replacing y with that expression, is equal to negative 3. Notice everything else in that equation stayed the same. Okay, I just replaced y with that expression. Okay, highlight just so you can see that real clearly. All right, then we're going to use our distributive property again to solve for x. Okay, we have 5x. Think of this as a negative 4 times negative 3x, so that's plus 12x. Then think of this as a negative 4 times positive 5, so that's minus 20 is equal to negative 3. Then we're going to combine like terms. 17x minus 20 is equal to negative 3. I'm going to add 20 to both sides. That's going to give me 17x is equal to 17. Negative 3 plus 20. I don't have room here. I'm going to divide both sides by 17, and x equals 1. Okay, so that is step 2. Step 3 says take this value, x equals 1, and substitute it into the revised equation from step 1 to find the other variable, to find y. Okay, so I'm using some little space here. I'm using y equals negative 3x plus 5. I'm taking that x out and I'm putting a 1 in its place. Okay, putting this in place of x. So y equals negative 3 times 1 plus 5, or y equals negative 3 plus 5. And there's my solution. We always write the solution as an ordered pair, in parentheses 1, comma 2 in this case. Always the x, then the y. Okay, remember to check that solution back into both of the original equations to make sure that it satisfies both. Once you've done that, then you've done all 4 steps. Okay, we're going to look at question 5 next. Question 5 is a little bit different because you'll notice the first equation in number 5 only has a negative 2. Y equals negative 2. Okay, and sometimes we look at that and oh, that looks different. I'm not sure what to do. Well, actually, this makes it a lot easier. They're telling us one of the coordinates already, one of the 2 coordinates that make up the ordered pair. In this case, they're giving us the y coordinate. okay? We just have to find the x coordinate. So what we do is we take this -2, we put it in for y in the other equation. Okay, just like we would if it were an expression, okay, just like we did up top. So 4x minus 3 times -2 is equal to 18. 4x, -3 times -2 is positive 6, is equal to 18. We subtract 6 on each side, we get 4x equals 12. We divide both sides by 4, and x equals 3. Okay, there's one coordinate, here's the other. Our ordered pair is 3, -2. Last one for today. Number 7. Here we have two equations, both with an x and a y. Neither equation has a variable isolated. Okay, now I will say that I think the first equation is a little bit easier to solve for y, okay, because it's a positive y, it doesn't have a coefficient. So all I'll have to do is add the 4x to both sides. Okay, if we tried to solve the second one for y, we could do that as well by adding 5x to both sides. But then we'd have a -1 in front of the y, and we need to divide both sides by that -1. Okay, you can absolutely do that, but I'm going to use the first equation because it's just a little bit easier. Okay, so we take that first equation, we add 4x to both sides, we get y equals. Okay, typically we're used to writing 4x plus 6 because we typically write it in slope-intercept form. In this case, you can just write it as 6 plus 4x. It doesn't matter because we're not graphing, so we're not really concerned with slope-intercept form. Okay, but it's up to you. All right, then we're going to take that 4x plus 6, we're going to put it in for y in the other equation. Okay, now be careful. We have a minus sign in front of that y. That minus sign stays there, so it's -5x minus the quantity, okay, you put your parentheses around y, the 4x plus 6, and then we have equals 21. Okay, this minus, again, it's like a -1, invisible -1. You can distribute, or think of it as taking the opposite of each term inside the parentheses. So -5x minus 4x minus 6 is equal to 21. Okay, -5x minus 4x is -9x minus 6 equals 21. We're going to add 6 to both sides, so -9x equals 27. Then we're going to divide both sides by -9, and x equals -3. Okay, that's half of our solution. That's one ordered pair, one coordinate, I should say, in the ordered pair. We're going to take that -3. Remember, it says to substitute it into the revised equation from step 1. Here is the revised equation from step 1. All right, so we're going to have y equals 4x plus 6. I'm going to take the x out. I'm going to put a -3 in its place. 4 times -3 plus 6. So that's y equals -12 plus 6, or y equals -6. My ordered pair is -3, -6. Again, I strongly suggest that you check that ordered pair back into both of the original equations to make sure you've done it correctly.